Wow. You know, every year when Connect rolls around and I get up on this stage, I remember once again just how special it is to be here. Because I look out at all of you, and what I see is the future. I see a remarkable collection of talented, creative, visionary people, the kernel from which the most important technology of the next 50 years will grow. I can feel the tremendous potential of VR just waiting for us to make it real. And that's why one of my favorite things in the world is talking about the future at Oculus Connect. Today is the fourth time I've had the privilege of giving a Connect keynote, and as I was thinking about what I'd like to share with all of you, I realized that this was the perfect opportunity to look back at what I've said about the future and see whether it still holds up. So let's take a stroll down memory lane. At the first Oculus Connect, I told you that VR was going to change the world. Although we're not there yet, I'm more certain than ever that that will happen. VR and AR, which, as I'll discuss later, will soon start to converge, are together going to replace personal computers and mobile as the primary ways humans interact with information and with each other. At OC2, I talked about how these are the good old days, because we're VR pioneers creating the future, a rare privilege that is all too often only appreciated in retrospect. And I talked about the key technology areas that would have to come together to take VR to the next level. 3 years later, I'm even more confident about all that. In my opinion, these are absolutely still the good old days, and they're actually going to get even better. Not only are we still creating the future, but over the next few years, we're going to see the rate of change accelerate sharply, and the future we're creating is going to be brighter than I predicted. As for the key technology areas, at OC3, I made specific predictions about where they would be in 5 years, and that's what most of today will be about. And yes, in case you're wondering, I do wear a blue shirt every day. It does not pay a prophet to be too specific. Overall, my 2-year predictions are looking pretty good, but I was perhaps a little more specific than I should have been. Not about the technologies themselves, but about their timing. I think most of what I talked about will be in consumers' hands a year later than I thought, 4 years from now rather than 3. But apart from that, not only are the predictions still on track, it's actually starting to look like I underestimated in some areas. I'll review my predictions in detail and update them a little later, but before I dive into that, I'd like to talk a bit about creating the future, starting with a quick story. As I described at OC3, back in 1995, John Carmack asked me for a second time to join him at id to write Quake, and this time I was ready to make the move. However, I'd never been to Texas, and I'd never met anyone else from id, so I took a trip down to Dallas to check things out. At some point during that trip, John and I went to Tia's Tex-Mex for lunch. By that point, I had decided to take the job, but I was not all that confident about my ability to do what John expected me to do. I had just climbed a mountain in shipping Windows NT, and Quake looked to be a much higher mountain, with no one but the two of us to write the code, and I was wondering if I would be able to hold up my end of the work. And actually, while it's not part of this particular story, feedback was not one of id's strengths. So I kept wondering whether I was living up to John's standards for a full 6 months after I started. If you've ever seen the movie The Princess Bride, there's a bit about Wesley being captured by the dread pirate Roberts, who initially spares him, but who tells him every night, "Good night, Wesley. Good work. Sleep well. I'll most likely kill you in the morning." Every evening, as I drove home, I felt like John would most likely fire me in the morning. Then one day, out of the blue, he said, "Everybody's happy with the work you're doing." What I didn't say then, but definitely thought, was that it was nice to finally know that I didn't walk away from all those Microsoft options and drag my family halfway across the country for nothing. Happily, in the end, working on Quake turned out to be one of the best experiences of my life. Anyway, after lunch, as I walked out to the car with John, I said that every time I start a challenging new project in an unfamiliar area, I wonder if I'm actually capable of doing something that hard, hoping he'd say something sympathetic or reassuring. John turned to me and said, "I never wonder that." Which is part of what makes John John, and part of why you should listen to every word of his keynote tomorrow. But while John would probably have no problem with the dread pirate Roberts, uncertainty is difficult for the rest of us. We mere mortals are far more comfortable iterating on what we're familiar with than plunging into the unknown, and it's much easier to follow taillights than it is to blaze new trails. That's especially relevant for VR, where we're all blazing new trails. It's hard for us not only technically, but also psychologically. That's just human nature. But it's also far more satisfying to dive into the unknown and succeed. The breakthrough work we did at ID was far more personally rewarding than if I had gone through another cycle of polishing Windows NT. For me, at least, work is satisfying in proportion to its impact and originality. And when it comes to impact and originality, VR and AR are as good as it gets. When I say that we're creating the future, I mean that literally. The world our children and grandchildren live in will be defined by the work we're doing today. Technological waves like VR and AR don't just happen. They're driven by a critical mass of smart, motivated people with a vision, people like all of us together. So please keep that in mind as you encounter the inevitable obstacles and frustrations of forging into the unknown and creating the future. In that context, it's instructive to look at the PC revolution, which is the closest analogy to what we're collectively doing with VR. PCs and their mobile descendants are the core of the first great wave of human-oriented computing, the greatest change in how we live in nearly a century. That wave came together in the 70s at the Xerox Palo Alto Research Center, where a team of researchers took on the mission to create the office of the future and invented the laser printer, developed Ethernet, refined the mouse and developed the bitmapped windowing interface, wrote the first WYSIWYG word processor, even coined the term object-oriented, and then put all that together to build the first personal computer, the Alto. Steve Jobs negotiated 2 visits to see the super-secret Alto in 1979. Here's what he said about that years later. And within 10 minutes, it was obvious to me that all computers would work like this someday. It was obvious. You could argue about how many years it would take. You could argue about who the winners and losers might be. You couldn't argue about the inevitability. It was so obvious. The Macintosh and Windows spread the technology Park had created. Developers built the software we use today on that foundation. Moore's Law enabled computers to get much smaller and 1,000,000 times faster. And the result is a world in which all of us make our living using personal computers and communicate and stay in touch with smartphones. So the first great wave of human-oriented computing didn't just happen. The foundation was created by a team with a critical mass of talent and a vision at Park, and then an ever-expanding community of developers and hardware companies built that out into the world we live in today. Now let's apply Steve's words to the second great wave, VR and AR. You couldn't argue about the inevitability. It was so obvious. Imagine a VR headset that's a sleek, stylish, lightweight visor with a 200-degree field of view, retinal resolution, high dynamic range, and proper depth of focus, with audio that's so real you can't believe it's computer-generated, that lets you mix real and virtual freely, that lets you meet, share, and collaborate with people regardless of distance, and that lets you use your hands to interact with the virtual world. If that existed, we'd be working, playing, and connecting in it every day. Imagine AR glasses that are socially acceptable and all-day wearable, that give you useful virtual objects like your phone, your TV, and virtual workspaces, that give you perceptual superpowers, a context-aware personal assistant, and above all, the ability to connect, share, and collaborate with others anywhere, anytime. If those glasses existed today, we'd all be wearing them right now. That's all obvious. And while it may be hard to believe, it's all doable. We really will be wearing those AR glasses and working, playing, and connecting in VR before too long. There's just one minor obstacle. The technology that would allow most of that to happen doesn't yet exist. But it will. Now, that's possible partly because there's a new, very positive twist to the future that I envision for VR. When I made my predictions 2 years ago, they were based on my extrapolations of the research and development work we'd been doing in VR. Since then, though, our work on AR has ramped up a great deal, and over the last 2 years, 2 important points have become clear. The first is that VR and AR have a great deal of overlap. It's always been obvious that 20 or 30 years from now, you'll just have one pair of glasses that supports everything from purely virtual to entirely real. But technology limitations, especially in the display, have forced completely separate VR and AR paths to date. For those same reasons, VR and AR products will continue to be on different paths for a while, with VR providing the richest, most immersive experience, while AR gives you all-day, socially acceptable access to information, virtual objects, telepresence, and a virtual assistant. But the technology they're built on and the functionality they provide will increasingly converge, especially as VR acquires good mixed reality capabilities. This is no longer a someday thing. It will happen over the next decade, and I expect it to start to have a major impact in 4 to 5 years. The second thing that's become clear is that VR can advance farther and faster by leveraging AR technology. Now, VR didn't require breakthrough technology to become product-worthy, and in fact, most of what you'll find in a VR headset is modified off-the-shelf technology. That doesn't mean that it was easy or that current VR isn't good. It just means that when you can, for example, make a good display system using technology developed for smartphones, you don't try to develop a completely new, risky display system that might be even better. But no off-the-shelf display technology is good enough for AR, so we had no choice but to develop a new display system, and that system also happens to have the potential to take VR to a different level. The same is true pretty much across the board, and it's why I said at the beginning that we're going to see the rate of change for VR accelerate sharply, and that the future is going to be even brighter than I predicted. Having said that, I'll say the same thing I said 2 years ago. What you're going to hear is what I think and hope the future of VR will be, but what I'll discuss may or may not ever show up in a product. So with the clear understanding that these are just my opinions and that there are no guarantees, let's revisit these predictions. Here are the areas I made predictions about at OC3. Let's look at each of them in turn, starting with optics and displays. We're visual creatures, and the display is the most prominent part of the VR experience. Here's what I predicted for 2021: 4K by 4K panel resolution, 30 pixels per degree, a 140-degree field of view, and variable depth of focus. That's actually only 3 predictions because pixels per degree is a function of total resolution and field of view. This is a case where I clearly undershot. Many of you no doubt saw the description of the Half Dome prototype at F8. Half Dome achieved 2 of my 3 display predictions 3 years early. It has a 140-degree field of view and varifocal depth of focus. And while Half Dome has roughly the same resolution as the Rift, 4K panels that would provide 30 pixels per degree over a 140-degree field of view have already been shown publicly, and using one in Half Dome would be straightforward. So I'm comfortable saying that I nailed this prediction. However, one thing that I didn't predict 2 years ago was equally rapid progress on the algorithms driving varifocal displays. Without varifocal, everything appears blurred when you look at a nearby object, such as this robot's hand, an unnatural condition that is obviously not an ideal visual experience. With varifocal, both near and far objects always appear sharp. This is also an unnatural condition that, while better, is still not an ideal visual experience. Fixing this requires rendering depth of field blur that varies depending on where you're looking, which is very challenging to do in a physically accurate manner. However, we've made significant progress on solving this problem with deep focus, an AI-driven renderer that can reproduce natural gaze-contingent blur in real time. Here's correct blur when looking at the robot's hand. Notice that the hand is sharp, while the background is properly blurry. And here's the correct blur when looking at the far wall. In the coming months, we'll be publishing our deep focus research and making the trained networks freely available to experiment with and build upon. So Half Dome and deep focus are very cool, but that's just the start for optics and displays, which is the poster child for how progress is accelerating. There are actually 2 ways in which we're already moving past Half Dome, and both of them have tremendous potential. One of these is a technology known as pancake lenses. Pancake lenses have been around for decades, but are only now becoming truly practical. They use polarization-based reflection to fold the optic path into a very small space, which results in several advantages over the Fresnels that are currently used. For one thing, they enable much sharper images, allowing full benefit from higher resolution panels. Given the right panels, they could potentially reach retinal resolution. They can also support ultra-wide fields of view, all the way out to somewhere around 200 degrees. Finally, they enable much more compact headset form factors. That all makes pancake lenses very appealing, but I should note one limitation. You can get either a very wide field of view or a very compact headset with pancake lenses, but not both at the same time. So pancake headsets may be optimized for form factor and comfort rather than field of view, but if so, that will be a choice because they could have had an ultra-wide field of view instead. I'm not making any predictions about whether or when pancake lenses will ship, but they make it obvious that the rate of change has ramped up from what I anticipated 2 years ago. Remarkably, though, the long-term display technology slope is actually steepening even more thanks to AR technology. That comes in the form of waveguides, where light is injected into a thin glass plate and bounces down it, getting deflected out towards the eye a bit at a time as it bounces along. Waveguides are only a few millimeters thick, so it's possible to make extremely slim, light displays with them. There are no inherent resolution limitations, and they could potentially extend to any desired field of view in a slim form factor, so it would be possible to build a sunglasses-like waveguide visor with retinal resolution. Here's a concept drawing, which I want to emphasize is not an actual prototype, much less a product, of what a waveguide VR headset could look like. So while something like that is still years in the future, it's so compelling that I expect it to eventually happen. So for display, not only have my predictions already come true, but I'm more excited about the future than ever. Next, we come to graphics. Here, my prediction involved foveated rendering, where rendering resolution varies across the screen to match that of the retina. Here's what might actually be rendered as the eye moves around a scene. The white square shows where the eye is looking. As you can see, detail falls off sharply away from the foveal area, and most of the scene is rendered very coarsely, saving a great deal of rendering work. This sparse rendering can then be upsampled into a normal full-resolution frame buffer that is perceptually indistinguishable from a full-resolution render when viewed in a VR headset. My prediction was that foveated rendering would be used to decrease the rendering load by an order of magnitude. I think that prediction will hold up, but what I didn't anticipate was how the missing pixels would be filled in. A new and very promising approach is to use deep learning to fill in the details. The generated pixels won't be exactly right, but because they're away from the fovea, that doesn't matter. What's important is that it will look right to your peripheral vision. Let's look at an example. Here's a full-resolution image. Now, here's that same image with 95% of the pixels removed in a pattern that matches the distribution of resolution across the retina, assuming that the viewer is looking at the white square near the lower right. Now let's use deep learning to fill in the missing pixels. It's not exactly right, of course. A lot of detail is lost as you move away from the white square, especially if you look at the mountains and fields at the left side of the screen. Here, let's do a blink comparison to make that clearer. Here's the original, and here's the deep learning reconstruction. But those differences would be indistinguishable from the original image when looking directly at the white square in a VR headset. And the reconstructed version requires rendering only 1/20th as many pixels as full resolution. Here's the deep learning approach applied to the sparse rendering we saw in the earlier video. If you look closely, you can see that there's fine detail only around the white square, but again, this would look exactly right to someone whose eyes are following the square. There's still a lot of work to do here, but I'm comfortable sticking with a prediction of foveated rendering within 4 years. The other major challenge with foveated rendering was the requirement for eye tracking. 2 years ago, I predicted we'd have great eye tracking, but I thought it was a significant risk. It's still a risk, but I'm more comfortable than I was 2 years ago in saying highly reliable eye tracking will be here within 4 years. After all, it obviously works in Half Dome today, and while that's not the same as working across the entire population in a shipping product, getting the rest of the way there should be doable. I had 2 predictions for audio. One was that there would be solid technology for modeling the propagation of sound around virtual spaces. That is, how sound reflects, diffracts, and interferes as it bounces around. So virtual rooms would feel much more convincing, even though you might not consciously know why. The first propagation code is already on its way into product, and that will steadily improve over the next few years. The other prediction was that personalized head-related transfer functions, or HRTFs, would become a standard part of the VR experience. HRTFs describe how sound bounces off and diffracts around the head, and especially the ears, which is the key to enabling truly convincing directional sound. Now, you might think that sounds nice, but not particularly significant, kind of like a better form of stereo. And I might have agreed with you until recently. But a few weeks ago, I had my first demo with my own personalized HRTF. I put on special open-ear headphones and sat down in front of a table that had a cassette player on it. A researcher put a cassette in and turned the player on, and music started playing. She picked up the player and moved it around me, and I listened as it happened, wondering what the point of this was. I was asked to close my eyes and point to the player, and I did it successfully about a dozen times. Then she put it down and popped out the cassette, and the music kept playing. It took me a minute to understand that the player had never made any noise. The sound was entirely from the headphones, but spatialized perfectly as the player moved. Even once I understood that, it was so convincing that I had to lift the headphones away from my ears to prove to myself that they were really the source of the music. It was like no computer-generated audio I've ever heard before, and it was utterly convincing. Audio presence is a real thing. Personalized HRTFs are going to be a huge step forward for the VR experience, especially paired with great visuals for multimodal impact. However, they're also one of the riskier of my predictions. Obviously, they're currently doable, but the challenge is to make the process of generating them a lot easier. My HRTF was the result of a 30-minute scan of my ears, followed by a lengthy simulation, which definitely doesn't qualify as consumer-friendly. I'll stand by this prediction, but I acknowledge that it may take longer than I thought. For interaction, by which I mean the ways in which we make selections and perform actions in the virtual world, my prediction was that we'd have good hand tracking and gesture-based control of simple interfaces, with touch continuing to be the preferred mode for sophisticated interactions, and I'll stick with that. I also noted, though, that the only thing that I thought could fully displace touch-style controllers was the ability to use your hands directly, complete with haptics, to interact with objects in the virtual world, and that I didn't think that that would happen in the next 5 years, that in fact, it wasn't even on the distant horizon. I still don't think it'll happen in the next 4 years, but something interesting may in fact be on the distant horizon. This is definitely a deep research problem right now, but here's a video of one experiment. I predict the first time you get to use your hands with haptics in VR will be as much of a revelation as the first time that you put on a VR headset. Because that feedback loop from head motion to proper parallax is what creates strong presence in VR today, and I believe that that feedback loop from motor control to haptics can be equally powerful. So I don't have a 4-year prediction for haptic hands, but I'll make the farthest out prediction I've ever made and say that I believe that we'll have useful haptic hands in some form within 10 years. For ergonomics, my primary prediction was untethered headsets, but I also predicted greater comfort overall. This is an area in which the AR-VR connection really shines. The reason is that, in my opinion, in order to be successful, AR glasses have to be socially acceptable, weigh no more than about 70 grams, and dissipate no more than roughly 500 milliwatts on your head. Compared to that, VR ergonomics are a piece of cake. Applying AR technology to VR, especially display, silicon, audio, and computer vision, will make it genuinely possible to build something like the visor I showed you earlier. There's also another aspect of AR that will help to enable a hyper-comfortable visor 4 years from now, and that's a 2-part architecture. Given the thermal and weight constraints, it's not feasible to get enough compute into a pair of socially acceptable glasses to enable truly useful AR. So AR glasses will have to be linked to a companion device, either a phone or a puck, that has most of the battery and compute. VR can similarly link the headset to a companion device, and that will reduce the weight on the head drastically, vastly improving comfort and overall form factor. Better yet, VR headsets could link to the companion device wirelessly, giving you complete freedom of motion. Of course, freedom of motion in VR comes with the challenge of moving around safely, and here we come to computer vision and mixed reality. That is, freely mixing the real and virtual worlds by reconstructing the real world and bringing desired parts of it into VR. Let's look at an example of reconstruction. First, the space needs to be scanned. This can be done manually, but can also be done automatically as a person wearing a headset moves around a space, as you see here. As the headset moves, the sensors sweep around the space, cumulatively building up a model of it over time. Once the space is captured, the model can be pulled into VR and played back, mapped to the real world. It can also be broken down into its major parts. And it can be reskinned. Basically, at this point, real and virtual can be intermixed however you want. So that was pretty cool, but it was obviously a research video with plenty of artifacts. Can reconstruction get good enough to be really compelling? Well, here's a picture of a real apartment. Now, here's a reconstruction of that apartment done with consumer-grade sensors. Every time I see this, I'm astonished at how realistic it looks. It's easy to see how this level of reconstruction will enable virtual teleportation and powerful mixed reality. As we saw, a model of this detail and complexity takes time to construct. Instant real-time capture and reconstruction of the real world is also possible. It won't be as complete and polished, but will let you move around safely, interact with real objects, and mix real with virtual effectively. And that will be here within 4 years as well. Overall, computer vision capabilities are advancing rapidly, and I'm happy to stick with my prediction of high-quality mixed reality within 4 years. Now, mixed reality has implications beyond just expanding the range of VR experiences. Once we have good mixed reality, VR and AR suddenly have a great deal in common. For social reasons, you're probably not going to be walking around in public wearing a VR visor anytime in the near future, but otherwise, what difference does it make whether the photons showing you the real world come from the real world or from a display? In fact, mixed reality in VR is inherently more powerful than AR glasses because there's full control of every pixel rather than additive blending. VR can also provide a richer experience than AR because the display doesn't have to be see-through, the form factor is much less constrained, and it doesn't have to run off of a battery for an entire day. So the truth is that VR is not only where mixed reality will first be genuinely useful, it will also be the best mixed reality for a long time. AR's advantage, on the other hand, is that it will make mixed reality available all day, anywhere you go. But both of them will be mixed reality platforms with a great deal in common. This commonality leads to some important conclusions. If both VR and AR let you mix real and virtual, why would they have different user interfaces? Sure, they would use different controllers in different situations, but they should ultimately use the same underlying interface tailored to specific uses. Similarly, they should have the same developer environment and tools, and apps should generally work seamlessly across both, although some will obviously be better or more useful on one platform than the other. So VR and AR should converge in many ways over the next decade. And finally, we come to my last prediction, virtual humans. Truly lifelike, real-time virtual representations of real people, which I didn't think would land within the 5-year horizon. That may still prove to be right, but this may be another case where I was insufficiently ambitious, because the rate of change is accelerating here too. Consider the face tracking video I showed 2 years ago. Now contrast that with this.
A good morrow to you, my boy. It's healthier to cook without sugar. Thank you, she said.
It's hard to believe, but one of those is a reconstruction, not a video. Can you tell which?
Statuesque composure.
The one on the right is the reconstruction. If you look closely enough, there are imperfections in the neck, the hair, the eyes, and the mouth, but it's impressively close to the real thing.
Thank you, she said, dusting herself off. George is paranoid about a few.
This is a novel machine learning-based approach we call codec avatars. And while it's still in an early stage, if it could be made to work for everyone and included bodies and hands, it would revolutionize how we communicate and collaborate. Put it together with mixed reality, and where you live would no longer have to be tied to where you work. You could visit, really visit with your family, even if you lived thousands of miles away. And of course, it would enable by far the best multiplayer games ever made. So I'm not betting on having convincingly human avatars within 4 years, but I'm no longer betting against it either. What's particularly interesting to me about the possibility of truly convincing virtual humans in the near future is that it is the last piece of the one thing I personally most want from VR. As I said 2 years ago, I would love to have a virtual workspace. A VR environment that you could configure any way you wanted with virtual screens, holograms, whiteboards, and whatever, then switch between configurations instantly. That's the most productive solo work environment I can imagine. And then, if we add virtual humans, it would become an amazingly productive collaborative environment as well. If all of my 4-year predictions come true, and virtual humans also lands, then a virtual workspace that replaces personal computers is a done deal. The only thing that that VR system would lack is true haptic hands, and that may well show up a few years later. Now, imagine that you have that powerful virtual workspace, and then AR glasses come along and let you seamlessly access that same workspace no matter where you are. True, the experience won't be as good, but you'll be able to do it anywhere, in a cafe, in a meeting, in an airport, wherever you want. You'll have the best workspace in the world when you're at your desk in VR, and you'll be able to access a lower fidelity version of the same workspace anytime, anywhere in AR. That's a future I look forward to with great anticipation, and one that I expect to see within the next decade. And with that, we've come to the end of my predictions. The bottom line is that things are pretty much on track. True, it will be a year longer than I thought before most of this lands, but on the other hand, some important areas are advancing faster and farther than I anticipated, so I think that's a fair trade. 4 years from now, VR is going to jump to the next level, and that's just the start. Every area will continue to improve, and virtual humans and likely haptic hands will be along before too long. In short, as far as I can see, and I can see pretty far, the future of VR couldn't be brighter. We, all of us gathered together today, both physically present and in VR, are quite literally creating the future. Our work is going to have a huge impact on how people live 10, 20, 50 years from now. Think of how much the world we live in has been shaped by Xerox PARC and everything that followed. What we're collectively doing now will shape the future even more powerfully. A technology wave like this comes along only once every few decades, and we are all unbelievably fortunate to be here for the beginning of this one. We're positioned to connect the world in ways far beyond anything that's ever existed before, and to make people more productive and their lives more fun while we're at it. Years from now, I promise you, we'll all look back on this as a golden time, a time when we literally made the future together. Thank you.